Hi again, everybody. This is Joseph with a tutorial again, discussing automotive schematics, how to read a schematic and how to analyze. The viewer actually asked me a question, again, how to first understand the symbols and then how the purpose of them, applications. So we're going to first start, as I said before, the relay or the fuses. It does not matter which make or model, which application it is in. The purpose is the same. It doesn't matter if the relay is in a Ford, Honda, Chevy. The purpose is the same, to control another part of a circuit. Fuse, circuit breaker, which are protective devices, doesn't matter if it's in a Ford, in a Chevy. Its purpose is the same. So, like I said, once you know how it works, you can apply that theory to every make and model of automotive. As always, first we always break down where we have a schematic. Where do we start? Where's the starting point? Where are the main components? Main component is the relay, always. There's a module over here called the body control module, which is responsible for controlling lights, seat belts, motors, all accessories. The loads are the bulbs themselves. So the starting point is always from the top, usually. Again, we don't see a schematic symbol for battery, but we know voltage has to come from somewhere to supply current. So therefore, at the top over here, this is in a fuse panel, as indicated by this dotted square. That all of this is located in a fuse panel, this fuse and this relay. Hot at all times means battery is always connected to it. Now, a starting point, like we said, we start over here. A denotes somewhere else in the schematic, that there's somewhere else noted as A also. So there's a continuation of this point to another point, which would also say a triangle A. If it would be B, there would be another point somewhere in the schematic that you have to look where it's also connected to B, because you don't want too many lines drawn all over. So what do? You just take this and put this as A, and you find the other part A wherever it is. You don't want lines all over. It's confusing. That's the reason for that. As we said first, the starting point is here. Now, we first said we need current flowing through a relay. It does not change regardless of which make or model it is. It's just, theory is the same. We need to magnetize this coil. That happens when current flows through it. We see this is ganged together. That means when this is activated, the contact is being pulled in and it makes contact with this part of the circuit. Again, same theory regardless of any schematic. Does not change. The other part we have to understand, on one side of a relay it has to be plus, and the other side of the relay has to be somehow a ground. So we have to work our way from the schematic and say, okay, this point we have B plus. It says hot at all times. Obviously it's connected to a battery. The other point somehow has to come to a ground to complete the circuit. Let's see if this is true. As we said, this is a BCM. You have body control module responsible for connecting one part of a circuit to another part of a circuit based on the accessories. Let's say you have daytime running lights, so you need the lights on in the daytime by photo sensors on the dashboard. This dictates the relay to connect it to this, thus giving you all the lights. Therefore, we need this. We need this switch. If this switch would be in this position, guess what? There's no connection. You don't see any connections here. When do you see connection? When the switch is flipped in this way. Therefore, we can give a couple of theories. We need B plus here, relay. We need a ground. Computer could give a ground, or a mechanical switch could give a ground. In this case, we have a computer board called a body control module, and usually every make and model they call it body control module. It is responsible again for the accessories, for the lights, for the seat belts, for what's it called, for other things, any accessories that go on, except engine performance. That's the PCM. Anyway, daytime running lights comes from BCM. So therefore, this switch has to be in this position. When we close this switch, we flip it. Guess what? Now we have current flowing through here, and this is ground. There's our complete path. That takes care of that. What about the other part of it? Well, what do we say? When this is activated, this is activated. So in which position would this conduct current? Well, right now there's no connection here. That won't help us. But there is a connection over here. So we flip this switch, this side to this side. Now we have a connection. So current flows. Here's a node. Here's a branch. Here's another branch. Right? 2 branches. Current goes here to activate this. Then current flows here, because this is flipped in this position. Follow the pink arrows. Current is flowing through this fuse, rated at 10 amp. Again, rear fuse block. Now, when we come to this point, we have 2 choices, 2 paths. We have this path, we have this path. So what do? We look what these are connected to, right? Cornering lamps, left and right. We have a switch here, it's a main component. We have another one over here. Where does this go to? This goes to the parking lamps and the marking lamps, right and left. Those are the loads, those are the lights. So therefore, if we're in right position, remember one thing, we need to put this, you have 2 choices, to put in left and to put in right. Over here, no connection, it will not help us, neutral. We flip it this way to left, right? Current, as we said, flows through the fuse, comes out the other side of the fuse. Takes this path through the brown wire. And if you notice, some make and model, some people, some manufacturer model, they have different abbreviations for the wires. One was BN, one was BR. This is BRN, so it's brown. BLK is black, gray. So everybody has its own abbreviations, but you can figure it out pretty much. Or ORG is orange. Again, this is tan. This is white. Following this, we said we want to put the left bulbs on. Follow this path, and guess what? Turns on this. The left cornering lamp. The lamp is on. Going to ground. That's a complete path for us. So we're on this path. What about the other path? Let's follow this path. This path, brown wire. Brown wire. We want the left bulbs to go on. Now, come to an interesting point over here. Very interesting point. Now, when we come to here, we have 2 paths also. A brown wire. This current will go through the brown wire through the left front marker lamp. As you see over here, there's no connection between this one and this one. So current will flow through the brown, out the light blue wire, back up here. Again, it's the same wire, light blue here, over here, and this is double filaments in the bulb, out the black one, the ground. That's one path. One path, boom, through the left front park turn signal lamp over here. And these are 2 together. And then the other path will be, guess where? Here, here, here. So this path is much easier than this path. This path has 2 lamps it goes through, see? And this has 1. What about here? That's the left. Guess what? Now we have another one. Now we also have the right. One path will go, again, through this, through a marker lamp, dark blue, through the brown, out the darker blue, dark blue, here, out here, and here. And the other one will go through the bulb. Same as this. So these will be lit, these will be lit. What about right? Right cornering lamp will be here. So the only thing that changes are the cornering lamps. Which one will be lit? But as far as this is concerned, all these come on at the same time, and you want them to come on at the same time. You want the right and the left parking lamps to come on, and the signal lamps to come on, and the marker lamps to come on. So therefore, the only thing that changes again is the left cornering lamp and the right cornering lamp, and that you do by the switch. When you flip it this way, go this way, and this one. This one will be lit. Okay? So, like I said, it takes practice and practice and practice. But basically, if you understand how the relay works, if you understand you need a ground, you need a B+, you need to close this to activate this because we need a complete path, then you understand one part of it. You understand the other part of it, the fuse can be on top of here also. The fuse can be over here. In this case, it's over here on the controlled side of the relay. Okay? So therefore, again, if I have one bulb out, fine. I know it's the bulb. Let's say I have this one out. These are out. I look at my car in the morning. The left marker lamp is out. The left parking signal lamp is out. The right one is out. Both of these are out. Now I can't just say it's, well, coincidence, so many bulbs are out. Impossible, right? What do? We have to come back here to this situation and say, you know what? Yeah, it could be the fuse. Could be the fuse. But it could be also the relay was not activated. Right? Maybe this part of the armature or the contact is not flipping. What about the other side? Well, if we have current over here and we close this switch, we will measure 0 volts over here. 0 volts. That tells us that this is grounding. So 12 volts here and 0 volts here. Now we can jump this. We can jump this part and see if all these come on. If they come on, that means there's a problem obviously in the relay. So you take a jumper, I'll show why from here across here. You could do that as a quick test. Or you could go to this part of it and say, okay, let me measure 12 volts. If I measure 12 volts at the fuse, then I know this is working. This is correct. Sometimes, like someone asked me, it's hard to find a component, and it's hard to get to a component. Like let's say if you want to get to a relay, you can't get under the relay to measure it unless you put an inserter, and then you put the relay in it. The easier thing is you see where it's connected to. This point out here is the same point as this point. So if I can't get access to this point, the relay, I can go to this point. Or I could go to this point. If I go to this point and I get 12 volts, that automatically tells me that all of this is connected to the relay, and the relay has been activated and pulled in. Right? Let's say all the bulbs work, but the right cornering lamp doesn't work. Does the left cornering work? Well, I try and flip the switch. Yes, the left one works, but the right one doesn't work. I'll assume, okay, it's this. Right? It could be the switch, yes. If the switch is stuck in the left, that means the left will always be on, even when I flip the switch to the right. If none of these work, that means this is stuck in this position, and obviously the switch is not good. So first, know where the starting point, where to start. Like I said, this is for a Toyota. Before we did BMW, pretty much same concept, right? Wherever we go, even if you go here, right? Here's a relay over here. Same theory. Here's a fuse. We have to put this switch. Flip this switch over here. And once we flip the switch, guess what happens? The park neutral position has to be in either park or neutral to start the car, as we always see. Electrically, what are we doing? We're taking the current goes through here. When we have it in the right position, if you have it in drive, it won't work. See, there's no connection. Only in park or neutral. So we flip this switch over here. When we have that, we're causing current to go through this one, starter relay, right? You can only start the car when you're in park or neutral. And this goes to the relay for the starter. Power train control module is like electronic control module. ECM, PCM, which is the abbreviation. Anyway, it's to start the starter motor. Current goes through here. We always said the same thing. It's ganged together, so this now is pulled in. You see, the theory is the same. The theory much is the same. Then we're going to get current to flow to the starter relay. To the starter. There's a solenoid, a relay. See these over here? Relays, solenoids they call them. And then there's the starter. We need this to open this. When you have this relay, being activated, you flip this switch this way. Guess what happens? Now current can flow to the solenoids, right? We're here. And activate the starter. Remember, we need the starter to crank the engine first. To the flywheel, then to the engine. You can't crank the engine first from the battery. You first need a starter motor. Okay, so the theory, see how the theory is the same? Still have a switch, still have a fuse. It doesn't matter which make or model, right? This being a Toyota. Relay, same concept. Same concept. Doesn't matter where it is, which make or model, but I know what the purpose of a relay is. I can apply it to this. I know how a switch works. I can apply it to this. I know how a fuse works. So all that matter is practice and practice and practice. See? Starter relay over here. Please subscribe to my channel, Automotive Electronic Schematics by Joseph. You'll see plenty of these diagnostic schematics and how to read schematics. And my other one is Joe Electronic Schematics, which is basically also transistor amplifiers, Ohm's law, other things. I hope that will catch your interest and will be thought-provoking. Glad to be of assistance and hope to see you in the future for other videos. Thank you.